All right, guys, today we are starting chapter 2. The first section that we're going to talk about, 2.1, is all about polynomials. And there's a lot of new definitions, a lot of new language that you need to get comfortable with. So pause the video. And since you weren't here for the bell work, I want you to copy down these definitions in your notebook really quick. So hit pause, copy these down, and come back. All right, so these definitions, monomial, this first one. A monomial is just another word for a term. So like 3x squared is a monomial. Mono means single, means one, right? So 3x squared is a monomial. -7 is a monomial. 16xy cubed is a monomial. And t to the fourth is a monomial. Even though this has a 16, an x, and a y cubed, they're all being multiplied together, so it's one term or it's a monomial, okay? Now, a polynomial is a combination of monomials. So if I add a bunch of these together, like x squared plus 6x plus 7 is a polynomial. 16y to the fourth minus 3y cubed plus y squared minus 16, that's a polynomial. And different polynomials, there's some special ones that we're going to work with, and you're going to hear these words a lot in the next couple of weeks. So a binomial, if you think about the word bi, that means two, right? So a binomial has two terms, x squared plus 7, 9x minus 3. Those are binomials because they have two terms. A trinomial, good guess, that has three terms. So x squared plus 9x minus 3 is a trinomial. And then the last definition, a degree, is the value of our exponent, okay? All right, so now that that's out of the way, let's get on with some math. Example number 2 in the book says to write a polynomial in standard form. And it gives me, let me zoom in here a little bit. It gives me this polynomial. And it wants me to write it in standard form. What standard form means is that the term with the largest exponent goes first. So right now I have 15x minus x cubed plus 3. So what I have are three different terms being combined. So this is a trinomial. And I want to put them in the correct order so that I'm in standard form. I pick the one with the biggest exponent first. So negative x cubed goes first. And then I work my way down. There's nothing with an x squared. There is something with just an x. That 15x would be plus 15x. And even though there's not a plus in front of it, it's a positive 15x, so it's like there's a plus, right? And then my last one would be the plus 3. So standard form, you just work your way down from the largest exponent, and then you always end with a constant, something that doesn't have a x or a y connected to it. So this would be my standard form. Pretty simple, right? Okay, classifying polynomials. Polynomials have a couple of different names. I'm not going to spend a lot of time on this, but again, I want you to get used to hearing the language. So in example number 3, it gives me 3 different polynomials, and it asks me to do a couple things. It wants me to write them in standard form, and then label them what their degree is, and then name it what type of polynomial. So this first one, we're just going to go down the list. -3z to the fourth. That's only one term. So standard form is easy, because there's only one term. I don't have to move anything around. Degree, the way you find the degree is you look at the largest exponent. So this would be a 4th degree polynomial. And what type of polynomial is it? Well, there's only one term, so it's a monomial, right? Okay, part B, 4 plus 5x squared minus x. Standard form, my biggest x goes first, so 5x squared goes first. Then I work my way down, so then I'm going to do minus x and then plus 4. I start with my biggest exponent, I work my way down. Degree, again, I look for my largest degree, which is 2. So this is a second degree polynomial. And it wants to know what type of polynomial. Well, it has 3 terms, so it's a trinomial. Again, guys, we're not going to get too hung up on this stuff, but when I say trinomial, I don't want you to panic and not know what I'm talking about. When I say put something in standard form, I don't want standard form to scare you. I need you to be comfortable with that language, all right? So standard form of my next one, I have 2 terms. I have a plus q to the 5th and an 8q. So my largest term, my largest exponent is q to the 5th, and then I'm going to put plus 8q next. So this is a 5th degree polynomial. And what type is it? Well, there's 2 terms, so it's a binomial. That's all I'm doing. Standard form, what's your biggest exponent, and what type of polynomial is it? So I would like you to pause the video, and I want you to try number 5, number 6, and number 7. Take 30 seconds, do the same thing. Standard form, degree, and what type of polynomial. Go. All right, so for number 5, there's a 4 and a minus 9z. So the minus 9z would come first, and then the 4 would become a plus 4. Now this one's almost a little bit tricky because there is no exponent right here. Technically there is, right? Technically there's a little 1 right there. We just don't write it. So this is a 1st degree polynomial, and there's 2 terms, this one and this one. So it would be a binomial. Okay, number 6, I've got 3 terms, 1, 2, 3. So I already know it's a trinomial. I need to put them in order. So I look for my biggest exponent, which is a 3, and then I work my way down. Plus t squared minus 10t. So it's a trinomial, that's my standard form, and my biggest degree is a 3, so it's a 3rd degree trinomial. Number 7, I've got 2 terms, 2.8x and x cubed. Well, the x cubed goes first, and then plus 2.8x is going to go next. There's 2 terms, so it's a binomial. And what degree is it? I look for my largest exponent, which is that 3. So it's a 3rd degree binomial. All right, let's do some more interesting things, okay? Enough definitions and language art stuff. We need to be able to add and subtract these polynomials together. You already know how to do this. Adding and subtracting polynomials, another name for that is combine like terms. You guys have been doing this since, what, 6th grade? Combining like terms. So there's 2 examples down here. It wants me to add these polynomials together. So example A is, well, let's start with the parentheses. 2x cubed minus 5x squared plus x. And then it wants me to add another polynomial to it. So add 2x squared plus x cubed minus 1. Again, guys, you've already done this. You already know how to add these together. It's nothing different. We just gave the things names, right? This is a polynomial, and this is another polynomial. So now I just want you to add them together. So the nice thing about adding, there's nothing happening inside these parentheses that makes me need to keep the parentheses because everything's just being added together. So I can just make these parentheses go away. And to add polynomials together, I look for like terms. So this 2x cubed can only be added to other things that have an x cubed, which are right here. So I have 2x cubes, and I'm adding one more x cubed, so that becomes 3x cubed. All right. Now my minus my negative 5x squared can only combine with other x squareds. And there's two of them right there. So negative 5 plus 2 is negative 3x squared. Now my x, I've got a plus x and a minus 1 that are left. X's can only be added to other x's. So that x is all by itself, and that minus 1 is all by itself, okay? And I don't know if you've learned different ways of keeping track of your like terms. This is how I do it. I underline everything that goes together with the same number of dashes. So this would be my final answer. Notice that it's in standard form. I did my largest exponents first, and I kind of worked my way down. So let's do the same thing. Let's do the same thing with part B. So part B is 3x squared plus x minus 6, and I'm going to add another polynomial. I'm going to add x squared plus 4x plus 10. Okay? Now, everything is being added together. There is nothing inside these parentheses, if you remember from past classes, nothing inside that parenthesis can be added together. So these can go away now. And same with the second set of parentheses. Now I want to combine like terms. I want to add all of this together. So I look for the biggest exponent, which is a 2. And I want to find anything with an x squared. There's one more right there. Technically, there's a 1 in front of it, right? So 3x squareds plus 1x squared, that's 4x squared. Now I drop down to regular x's. So there's 1 x right there, and there's 4 more right there. So 1 plus 4 is 5x. And then negative 6 plus 10 is positive 4. I've used everything. I wrote everything. It's in the correct order. If for some reason you've had this in a different order, like the 5x was first, I would want you to rewrite it so that it was in the correct order, okay? Your final answer should always be in standard form. Largest exponent first, and you work your way down. So, before, you know what, let's subtract now. We can practice, again, this is review. We can practice all of this at the same time. Subtracting polynomials is the same thing, but there was one big mistake. I used to call it the 7th grade mistake back when I taught 7th grade. We're gonna have a sophomore mistake this year, but the 7th grade mistake. So if I have example A, it gives me 4n squared plus 5 minus negative 2n squared plus 2n minus 4. Now here's what I would refer to with the 7th grade mistake. There is a negative in front of a parenthesis. And sometimes 7th graders, because they are new to negatives, they forget what to do with that negative in front of the parenthesis. But you're in 10th grade now, so I'm sure no one has forgotten. Actually, a lot of you probably have. So this negative in front of the parenthesis, remember that is kind of like having a negative 1 being multiplied by the parenthesis. So what you have to do is take that negative and distribute it to everything on the inside of the next parenthesis that it's attached to. So this 4n squared and this plus 5, I don't have to do anything with those because there's not a negative in front of those parentheses. But this negative 1 is going to distribute to that negative 2n squared and make it a positive 2n squared. The negative 1 is going to distribute to the positive 2n and make it a negative 2n. And then it's going to distribute to the negative 4 and turn that into a positive 4. So the 7th grade mistake is forgetting to change the signs of everything in that second parenthesis. Don't make that mistake, all right? You don't want to make 7th grade mistakes as a 10th grader. Now I can combine like terms. So 4n squared, that's my biggest exponent, is a 2. So I'm going to combine that with the 2n squared. and that is 6n squared. Now I look for just regular n's. Minus 2n, I think that's my only one. And then I've got plus 4 and plus 5. So that becomes plus 9. And I'm in standard form. I wrote them in the right order, so I'm done. Okay, let's do example B. So example B is 4x squared minus 3x plus 5 minus another parenthesis, 3x squared minus x minus 8. Now I have a negative that I have to distribute. Whoops, I don't want to erase it. I have a negative that I need to distribute to everything in that second parenthesis. I don't have to do anything to the first parenthesis. That one's okay. 4x squared minus 3x plus 5. But the second set, that negative makes 3x squared a negative 3x squared. It makes the negative x a positive x, and it makes the negative 8 a positive 8. And now my parenthesis is gone. So let's look for like terms. 4x squared and minus 3x squareds, well, that's just 1x squared. You don't have to put the 1. I don't usually put the 1, but it's there, right? We just don't have to write it. And then I've got minus 3x's plus 1x, so negative 3 plus 1 is negative 2x. Now, if you can't do that in your head, if you can't do negative 3 plus 1 in your head, go ahead and type it in the calculator. If you have negative 3x's plus 1x's, you can't put negative 3x in your calculator, but you can do negative 3 plus 1 and get negative 2 and then put the x back on after you're done using the calculator, right? Okay, plus 5 plus 8, that is plus 13. And I'm in the right order, so I'm done. All right. You need to try some of these. So go ahead and pause the video. Some of you, I know you just skipped through this part, but this is where you get to find out if you learned how to do what you need to know how to do. And if not, where you are making mistakes. So pause the video, try number 8 and number 9 and number 10 and number 11, and let's see if you do them correctly. When you're done with those problems, come back. Okay, let's see if you did those problems correctly. If not, then we need to practice a little bit more, or you know what to look for, right? If you made a mistake, you know what mistake to look for. So number 8 is b minus 10 plus 4b minus 3. Now, there's no exponents on the outside. I don't have to worry about anything, so I can just go ahead and get rid of those parentheses and add things together. There's no squares or cubes. There's a 4b and a b. Remember, that's kind of like a 1b right there. So 1b plus 4b's, that's 5b. And then I have negative 10 minus 3. That's negative 13. So my final answer would be 5b minus 13. Number 9, x squared minus x minus 2 plus 7x squared minus x. I can't change anything in the parentheses, and it's just a plus in the front. So I can get rid of my parentheses, right? And let's look for like terms. X squared, we better just put one line under that one, and 7x squareds. So that's like 1 plus 7, so that's 8x squared. And then I have a I like this question, a negative x and another negative x. Now remember, it's like there's ones in front of those. So I have negative 1 minus 1, and a lot of you are going to want to put 0, but a negative 1 minus 1 is actually negative 2. So that's going to be negative 2x. And then I've got a minus 2 all by itself. So minus 2. And that would be my final answer. Okay. Number 10, now the tricky ones. P squared. Whoops, that's not where my parenthesis goes. P squared plus P plus 3 minus negative 4P squared minus P plus 3. All right, this one has a negative, so I got to remember not to make my 7th grade mistake, and I've got to distribute that negative to everything on the inside. So my first parenthesis stays the same. That negative makes the negative 4p a positive 4p squared. It makes the negative p a positive p, and it makes the positive 3 a negative 3. Wow, that was a mouthful. All right, let's add things together. P squared plus 4p squared, that's 5p squared. 1p plus 1 more p, that's 2p's. And then 3 minus 3 is 0. Those actually cancel out because one's positive, one's negative. So my answer is just 5p squared plus 2p. If you put plus 0, I wouldn't mark it wrong, but we don't need to put plus 0 because you're adding nothing, right? All right, number 11. See how you did on this one. Negative k plus 5. I like these questions that it gives you to try because it gives you common mistakes that people make. And it gives you a chance to learn from those mistakes. So this negative needs to get distributed to everything on the inside. Negative k plus 5 minus 3k squared plus 6. So now my parentheses are gone. I can combine like terms. The k squared is going to go first, but there aren't any other k's to put with it. So it's just going to be negative 3k squared. Please don't forget to take that negative with it, right? They're attached. They go together. Then I've got a minus k. I think that's my only one, so minus k. And then plus 5 plus 6, that's plus 11. And I'm in order, and that looks good to me. All right, so again, stuff that you already know how to do, you've seen, you've done. It's just got a different name to it, right? We're not just, now you're adding polynomials together, which is just combining like terms, but you already know how to do the math. So the exercises for 2.1. I want you to do numbers 13 through 16, numbers 22 through 38, numbers 54 and 53. Those are the ones that are a little bit more challenging, but I want you to try those, okay? Those are story problems. If you need help with the story problem, there's a story problem up here. Example number 6 is a story problem. It's a great problem. Use that example to help you with numbers 54 and 53.